Good day, everybody. How are you all? Today, we are going to talk about how to compare or how to test the difference between two means. And this is Z test. So, without further ado, I'll share my computer screen with you. Testing the difference between two means. Okay. So, I'll write a few things. Suppose a researcher wants to determine whether there is a whether whether there is a difference in the average age of nursing student who enroll in a nursing who enroll in a nursing program at a community college. College and those who enroll and those who enroll in a nursing program at a university. At a university. The research question is, does the mean age of nursing students who enroll in a community college or at a community college differ from the mean age of nursing students who enroll at a university. So my null hypothesis is null hypothesis is H sub 0, sorry, null hypothesis is H sub 0 is mu1 equal to mu2 and the alternate hypothesis is HA mu1 not equal to mu2. Okay. Where mu1 is the mean age of all nursing students at the community college, and mu2 is equal to mean age of all nursing students at the university. Okay, so let me create some space. So another way of stating the hypothesis, or another way of stating the hypothesis for this situation. The hypothesis for this situation is H sub 0 is mu1 minus mu2 equal to 0, and HA is mu1 minus mu2 not equal to 0. Okay. Okay. Now, what are the assumptions to do this height? Okay. So, what are the assumptions to test the difference, or to determine, I should say, test to determine the difference between the two means. The difference between the two means. Between the two means. Okay. One. So one of the assumptions is number one, the samples must be independent of each other. Independent of each other. That is, there is no relationships. There is no relationship between the subjects in each sample. Okay, so this is the first assumption. And there are two assumptions. Okay, this is the first one. Okay, create some space. The second assumption is number 2. The standard deviations of both population must be known. Both population must be known. And if the sample sizes are less than 30, the populations the populations must be approximately normally distributed. Approximately normally distributed. Okay. So okay, so we have to calculate our test statistic. Okay. So we have to collect independent samples from both populations and calculate the test statistic. Calculate the test statistic. Okay. So let me create some more space. We know the test statistic is of the form test statistic is equal to observed value minus expected value. Expected value divided by standard error. Oops, correct this. No. So observed value minus expected value in the numerator. That is divided by standard error. Okay. And if x1 bar minus x2 bar is the observed difference in the two samples. Difference in two samples. And mu1 minus mu2 is the expected difference in the means difference in the means of two populations. Means of two populations. Okay. Uh, no, I don't know that. Okay. In the two populations, then our test statistic is test statistic is okay is z is equal to x1 bar minus x2 bar minus the expected value, the difference in the two population means. Expected value is the hypothesized value in the null hypothesis divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. Okay. So in this, we have to note, see if I move a little bit. The standard deviation of the distribution of x bar 1 bar minus x2 bar, okay, which is also called standard error, is equal to sigma 1 square divided by n1 plus sigma 2 square divided by n2, where sigma 1 is the standard deviation of population 1, standard deviation of population 1, sigma 2 is standard deviation of population 2 of population 2, and n1 is sample size collected from population 1, and n2 is the sample size collected from population 2, Okay. So, so after calculating test statistic z, find the probability which is p-value of getting a test statistic of getting a test statistic as extreme as that calculated. Test statistic as extreme as that calculated. And then compare p-value with the level of significance, with the level of significance. Okay. And if p less equal to alpha, level of significance is alpha, then decision is rejected 0. And if p greater than alpha, decision do not reject it 0. Okay. So I will stop here today. If you have any question or comment, you can always write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. And please share this video with your friends if you like it. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time with another interesting problem, interesting concept. Take care. Have a nice day. Thanks for watching. See you next time.